Algebra 1, Lesson 81, Graphical Solutions, Inconsistent Equations and Dependent Equations. So, graphical solutions. We've had systems of linear equations that look like, that are really blurry. Okay, like this, where they tell us to solve using substitution or elimination. Now they're going to tell us to solve by graphing. So what we're going to see is that these systems of linear equations that we've been solving are actually lines, and we're going to solve them by graphing. So what we will do is we're going to go to our coordinate plane. We're going to focus, and then we're going to graph both of these equations, and then where they meet will be our solution. And I'll show you what I mean by that. So the first equation, y equals x plus 1, right? So I'm going to start by graphing that equation. So I'll come up with an x and y table. If I plug in 0, 1, and negative 1. If I plug in 0 for x, y will equal 1. If I plug in 1 for x, 1 plus 1 is 2, so y would be 2. If I plug in negative 1 for x, negative 1 and 1 give us 0. So now I have 3 points. I can graph this line. So if I go 1 and 2, that's 1 point. 0 and 1 is another point. And 0 and negative 1 is another point. If you're having trouble graphing the lines, go back, watch that video lesson, and you'll better understand how to graph these. But for the sake of time, I'm going to move on. So I'm going to go ahead and graph this line of y equals x plus 1. And it's a good idea to use graph paper for these problems, because unless you're drawing all your lines perfectly straight with a ruler, you might run into some problematic answers. Now, the next equation we have is, let's see here, we'll go ahead and erase this. Y equals negative 2x plus 4. And I'll go ahead and use an x and y table again. I'll use 1, 0, and negative 1 because those are my favorites. So if I plug in negative 1 for x, that's just going to become negative 2 plus 4, which gives me 2 for y. If I plug in 0 for x, 0 plus 4 is 4 for y. If I plug in negative 1 for x, negative 1 times negative 2, positive 2. Positive 2 plus 4 is 6 for y. Now I have my 3 coordinates again. I'll go ahead and graph 1, 2. Okay, I get that point again. 0 and 4, so 0, 1, 2, 3, and 4. And then negative 1 and 6, negative 1 and 6, all the way up there. So then I graph this line. Now, what we mean by solving by graphing is the solution to both of these equations is this point right here, where both the lines meet. This is our answer. Now, this point, we just checked the graph, is x is 1, y is 2. So at 1, 2. That is the solution to our problem. And that is the answer to these two systems of equations. So like I said, if you don't have graph paper, this can really mess up your answers, because if you're trying to draw lines and they're crooked, then where the lines intersect might not always be accurate. And you might not always have a point that both the lines graph that gives you the right answer. So brush up on how to graph your lines, and then maybe get some graph paper. I don't think I have any in the room, but maybe I'll get some eventually. And graph the lines. That'll give you your answer. So the x is equal to 1, y is equal to 2. Now let's talk about inconsistent equations and dependent equations. So whenever we have two equations of lines, the lines don't always intersect because we have parallel lines, right? So one thing that may happen as you do these types of problems is the lines might graph parallel to each other like this. Now, if the lines are parallel, they're never going to intersect ever, right? So, is there any solution to that equation? The answer is no. Luckily, we don't have to graph our equations to find out whether or not they are inconsistent. So these are inconsistent lines, meaning that they don't touch. So this is inconsistent. Right? Now, the other option that you might get is sometimes you'll graph a line. Let's just draw another one, like right here. Let's say we get a line and it graphs like this, right? And then you go to graph the other line and you find out that the other line ends up being on the exact same spot. And it just overlaps, right? So when you have two lines that overlap, we call those equations dependent. So this is two lines and they are dependent. So, inconsistent lines are parallel lines that never touch. Lines that are right on top of each other are called dependent. Now, we do not have to, like I said, we don't have to graph these to figure out what they are. We can also figure them out by using the equations and using substitution or elimination. Now, before we use substitution and elimination, we need to know two things. So, the first one is that inconsistent will be false. And consistent equations will be true. All right? Now, how do we figure this out? Let's go over two examples. So let's say we have x plus y is equal to 2, and then x plus y is equal to -3. And we have to find out whether or not these two equations are inconsistent or consistent. Now remember, I said inconsistent or false, consistent or true. So we'll use substitution or elimination to solve for these equations and find out whether or not they fall into the category of false or true. Now I see very quickly I can use elimination to solve this. All I have to do is multiply the bottom equation by negative on each side. So the bottom equation would turn into -x minus y equals +3. And then if I were to add the top equation, x plus y equals 2, I'd find out that the x would cancel, the y would cancel, so I'm left with 0 on this side, and then 3 plus 2 is 5. So, does 0 equal 5? The answer is no, that is false. So, this is inconsistent. Now, on the flip side, let's say we have two equations that look like this. I see I can go ahead and use elimination again to solve these. I would just have to multiply, or I could use substitution if I solve this top equation for y. So I'll do that. I'll go ahead and add x to each side of this top equation, and that will turn into y is equal to x plus 2. I can then take this value and substitute it for 2y down here. So I'll write 2 times x plus 2 minus 2x equals 4. So I'm rewriting this bottom equation through substitution, and then I'll solve it. So this distributes, so I get 2x plus 4 minus 2x equals 4. I'll add like terms. 2x and minus 2x cancel, so I'm left with 4 equals 4. This is true. So that means it's consistent. All right, that's it for this lesson. If you have any questions, let me know on Moodle, and I will see you in class.